Hi folks, we're going to take a look at page 263, number 10. So they give us the position function, s with respect to time t, and they want us to find the velocity of the object at time equals pi over 4. So in other words, we're looking for the velocity evaluated at pi over 4. But of course, the velocity is just the derivative of the position function. So the first thing I'm going to do in order to find the velocity is I just take the derivative of the position function. All right, so here I'm going to have to apply the quotient rule. So let's start. Derivative of the numerator is cos of t, okay, times the denominator function. So that's 3 plus cos 2t minus the numerator function, sine t, times the derivative of the denominator function. So derivative of 3 is just 0. In order to find the derivative of cos 2t, though, we need to use the chain rule. Okay, so our 2t is like our u. So the derivative of cos u is negative sine u. So negative sine of 2t. All right, and then I have to multiply that by the derivative of u. Derivative of 2t, of course, is just 2. Okay, and all that over the square of the denominator. So 3 plus cos 2t all squared. All right. Now, since I really only need the value of this velocity at one single t value, I'm not going to bother doing much to simplify. I'm just going to input this into my expression here as I'm only looking for that one value. So v at pi over 4, we're just going to stick pi over 4 into this equation here. All right, so cos of pi over 4, well, that's just 1 over root 2. All right, so here we have 3 plus. Now, cos of 2 times pi over 4, so 2 times pi over 4 is pi over 2. And of course, pi over 2 is just 0, so that's good. All right, minus sine of pi over 4, which is again just 1 over root 2. And then here we have sine of 2 times pi over 4. So 2 times pi over 4, again, is pi over 2. Sine of pi over 2 is just 1. So this is just going to be negative 2 in the bracket, okay? So simplifies pretty nicely. And then here, remember, cos of 2 times pi over 4 was 0. So I just have 3 squared in the denominator. So I just have 9. All right, so let's simplify now that we've got everything input. So we have 3 over root 2. And then here we have plus 2 over root 2. All over 9, and this is just going to be equal to 3 plus 2 is 5 over root 2. Just bring that into the denominator with the 9, so 9 root 2. All right, and I'm happy with this as the answer. I suppose if you really did want to rationalize, you could go a little further here and multiply numerator and denominator by root 2 and write it as 5 root 2 over, and root 2 times root 2 is 2, so 9 times 2 is 18. But like I said, I'm perfectly happy with this answer. Now, because this represents velocity, we need to be giving some units, and I look at the question, and I see that they tell us that the displacement is in meters, but they don't actually give us a time unit. So here we can just say meters per unit time, okay, whatever that happens to be. All right, so let's just recap here. So this is one of these questions that you want to make sure you don't overcomplicate it. They give you a position function. They want you to find the velocity at a particular time value. So just find the derivative position and then input that particular time value to find your velocity. Okay, that's it for this one.